So now we understand that why we have to deal with vectors in a specific manner. Okay, we have to know the rules of dealing with vectors. Okay, fine. So first we'll see some basic things, some representation that we are going to use. Okay, a vector is denoted by this arrow. Okay, this arrow depicts a vector. Okay, fine. This is a vector, and the tail of the vector represents the magnitude. Okay, so this length signifies the magnitude. That means if the length of the tail is more, let's say I take a vector like this. Okay, now the yellow one has a longer tail, right? That means the magnitude, and I can name the vectors. Okay, let's say the white vector, white one is, let's say, a vector. Okay, vector I'll be denoting by a, and a small arrow is put over it, so that it tells us that it is a vector quantity. Okay, and let's say this one is vector b. Okay, I have just named the two vectors. Okay, so now the tail of the vector a is shorter and the tail of the vector b is longer. That means the magnitude of vector b is more than vector a. So magnitude is denoted by this modular sign. That means the magnitude is of vector b is more than the magnitude of vector a. Okay, this is correct. Now they are pointing in the same direction, right? That means vector a and vector b, they have same direction, right? They have the same direction, right? So that means the magnitude of b is some scalar multiple times vector a. Okay, because the direction is the same. So I can also write from here that vector b this time with the direction is some k times some scalar k, some number k times the vector a. Okay, k can be 2, 3, whatever, depending upon what fraction, means how many times the tail of the vector a is the tail of the vector b. Okay, suppose for example, the tail of a is 2 meters. Okay, and this is the tail of this one is 4 meters. So this k is what, 2 times, right? So I can write from here, that vector b is 2 times vector a. K here becomes 2 times, right? A scalar, 2 is a scalar, just a number, signifies a scalar. Okay, magnitude. Fine, this is one thing. Okay, now also about vectors we can say this is one thing. Okay, now if I say take another vector here only, take another vector. Okay, I take a vector like this, exact equal in length as a, but in the opposite direction. Let's say this vector's name is c vector. Okay, the tail length of vector c is the same as vector a. It is parallel also to vector a, but in the opposite direction it is. Okay, it is in the opposite direction to that of a. Okay, so this time the k becomes what, -1. Okay, this time I can say the vector c is nothing but -1 times, or minus of vector a. Okay, their magnitude is the same. Okay, the magnitude is the same, right? So I can also say the magnitude of the vector c is the same as the magnitude of the vector a. But is vector a same as vector c? No, there is a difference of direction. Okay, so I can write c is minus of vector a, or I say that the magnitude of the two vectors, they equal. Fine, makes sense, right? Okay, now what else? Yes, a vector can be moved parallel to itself, and it's the same vector. Okay, what I mean to say here, that suppose the same vector, let's say the same vector a that I took here, let's say this a, this is the a vector. Now if you just pick it up and move it parallel to itself, it's the same vector. Okay, so I just select this. If I just select this, okay, select this vector, okay, pick this vector up and move it parallel to itself anywhere in the space. Okay, the arrow also, okay, arrow also you have to just you have to move the vector parallel to itself. It is still the same a vector. Okay, this vector is a vector only. Okay, it's not a new vector. Okay, this vector that was here, you just moved it parallel to itself like this, it is still a vector. Same is not true for a line. Okay, two parallel lines, they are not the same. Okay, one line and then another line parallel to it, they are not the same line. The equation of the two lines, they are different, right? But for vectors, one vector with the same length of the tail, the same magnitude, same direction, parallel to itself you move, they are the same vectors. Okay, or you can say there is this vector a and there is, let's say, another vector, there is another vector, let's say r. Okay, there is another vector r of the same length, of the same magnitude, pointing in the same direction, then the two vectors are equal and the same. Okay, so a vector is the same as vector r, there is no difference. Okay, you can use them interchangeably. Okay, fine. This is one more thing. So these are a few things, some facts that you have to know, okay, about vectors. So we dealt about the magnitude of the vector, the direction, minus, plus, scalar. Okay, fine. Let's see if I'm missing something. Hmm. So that's it here. So now if I say that, let me ask you a simple thing. If I say this is a vector A, the length is, let's say, 2 meters. Okay, the length is 2 meters. Okay, so and I take another vector, let's say 3 times the magnitude of this is, let's say, 6 meters, and it is parallel to A. Okay, let's name the vector something, let's say B vector again. Okay, and I take another vector, that is half the length of A, that is 1 meter only, but opposite to the direction of A and B. Let's name this vector as C here. Okay, fine. So now what is the relationship? We can relate the three vectors, right? We can relate the three vectors, right? We can say that, okay, vector B parallel to A, the direction is the same, but there is a difference of magnitude. So I can say B is 3 times the vector A. This is fine. And then what is the relationship between A and C? A and C, C is half in magnitude, opposite in direction. What is the relationship of B and C? C is 1/6 in magnitude, with that of B. Okay, whatever is the magnitude of B, it is C is 1/6 of that, and in the opposite direction. So for B, I will write here that it is, negative 6 times of vector C. Fine, makes sense, makes sense. So it's like this. Okay, now if I take another vector, let's say I take another vector like this, in this direction, same magnitude, the length of this one, let's call this vector as D vector. The name of this vector I have given D vector. Okay, this is not parallel to A, it is in some different direction, in this direction that I have drawn. The length of this one is 2. Can I say vector A is equal to vector D because the length is the same, the magnitude is the same? No, because there is a difference in direction. Okay, there is a difference of direction. A is pointing, A has some different direction, D vector has some different direction. Then even if the magnitudes are the same, the two vectors are not the same, right? But yes, their magnitudes are the same. So I can say that, okay, yes, the magnitude of A is certainly equal to the magnitude of the vector D. Fine. So these are a few basic things that you have to understand about how we denote things, how we deal, how we represent things, and the basic understanding. Okay, next we'll be seeing how to add the vectors. Okay, how to find out the resultant of the two vectors, right? What is the sum of two vectors? Fine.